Okay, so we're going to go in and solve this linear equation. And the first and most important step of this process is always making sure that the equation is actually linear. If it's not linear, then the process will not work and you just end up with a mathematical mess. The next thing you want to do is make sure it has the proper form. And I have the form written off to the side that you want to make sure that you have. And again, very important to make sure you have a leading coefficient of 1 on the y prime. And then you want to make sure the y is always on the left-hand side and you always have a plus sign in front of that coefficient. So this is very important to check for. If there's a subtraction going on between these two terms, then you want to make sure that negative is absorbed into that coefficient so when you find the integrating factor. Okay, so the next step then is for us to actually find the integrating factor, and it's always mu of the independent variable, which in this case is x, and that's always e to the integral of whatever coefficient you have, and in this case it's just the number 2. And that is with respect to the independent variable x. And that's a very simple integral. It's just going to be e to the 2 times x. You now take this integrating factor and multiply both sides of the differential equation by that integrating factor. So you're going to have your e to the 2x multiplied against your y prime plus 2y. And you're going to have that same e to the 2x multiplied with the 3 times e to the x on the right-hand side. The next step, of course, is to distribute that integrating factor. So we're going to multiply out and have an e to the 2x times y prime plus 2 e to the 2x times y. And over here, we can combine exponentials and get e to the 3x when we add them. All right, now the next step is very important, and a lot of textbooks skip over this, but it's very, very essential. You need to recognize the left-hand side as the product rule from calculus. And you'll notice here that we do have a derivative of the first times a second times plus the first times the derivative of the second. So this is in fact the derivative of a product. So we rewrite it that way. This is e to the 2x times y that we took the derivative of to get this 3 times e to the 3x. And once we write it as a derivative, we now want to undo it. So we need to integrate both sides, and we have to always use the independent variable. So we integrate both sides with respect to x. And in doing so, the integration and derivative process cancel out, and we end up with just e to the 2x times y. Over here, when we integrate, that's very simple. We just get an e to the 3x, and now we add on our arbitrary constant, capital C. The last step of this process is to always isolate the dependent variable y. So we do that by dividing both sides by e to the 2x. And that's going to give us our solution, which is y as a function of x is going to be equal to e to the 3x divided by e to the 2x. Well, that simplifies down to just plain e to the x. And then we're going to have a c over e to the 2x. And we can't call that a constant because a constant divided by a function is not a constant. So it's going to stay in this form here, or you could use the rules of exponents and rewrite it as y of x is equal to e to the x plus c times e to the negative 2x. And this function right here is the solution of our linear equation. Of course, you can always go back in and check your work by just taking this function and its derivative and substituting it back into the differential equation as a check.